a curve. Here's my curve. And I want to know the vertical tangent line on this curve, okay? And while you don't have to graph it, it helps you to graph it to see what you're doing. So let me just graph this. Can you guys, just by looking at this, do you know what shape it is? It's a cardioid, okay? It's like a circle with some sort of shift of 2. So let me go ahead and plug in 0 here. If I look in the 0 direction, I'm going to walk out 2. Let me plug in pi here. If I look in the pi direction, this is going to be 0. I'm going to walk out. Oh, no, sorry, that's not pi. In the pi over 2 direction. If I look in the pi over 2 direction, this will be 2 minus 2 times 1, which would be 0. Okay? If I look out in the pi direction, this will be 2 minus 2 times 0, which will be 2. If I look in the 3 pi over 2 direction, this will be 2 minus 2 times negative 1, which will be 4. You guys see that? So 1, 2, 3, 4. And hopefully you can graph fairly quickly because on the test you don't want to spend all your time trying to graph. Okay, so let me draw this. Okay, so it looks something like this. All right, and let's think about what the question is. The question is, where are the vertical tangent lines, the equations for the vertical tangent lines? Well, take a look at this and tell me how many vertical tangent lines am I going to have? 2. Do you see it? One over here. Where's another one? Over here. And I don't know. It might be up here. I'm not sure how I drew this card, but do you see 2 of them? And look what they're asking me for. The equation of the vertical tangent line. Okay, wait, let's stop. Do you remember we've done this before? And whenever we did this, we said, let's find the point where there's a vertical tangent line. Do you remember that? And that point was r theta. Okay, so this point is going to be r theta. So whatever that point is, it's going to be r theta. Okay, this is a polar graph. So right here it says, find the equation of this vertical line. Guys, if it's a vertical line, and even though it's a polar curve, remember, polar curves sit on xy plane. Okay, the grid is just embedded, okay, on top of an xy plane. So this is an xy plane. What is this equation for a vertical line going to be? X equals something, right? So I know this is going to be x equals something, and I know this line is going to be x equals something. But if everything's in polar, what is x equals equal to? Do you remember? X is equal to r cosine theta. And over here, x is equal to r cosine theta. And I just want to say, on your test, if you get stuck on your test, it's really, and it's not a vector problem. If it's a polar problem, it's really because you just need to write one of these formulas down. So I'm just letting you know, if you get stuck on your test, just write one of these formulas down and see if that will help you. Okay, chances are this is what you're forgetting. Okay? All right. So see if this makes sense. What I'm going to do is I'm going to find the theta where this happens, where this point is and where this is. If I know the theta, I can use this equation to find the r. Agree with that? And if I know the r and the theta, then I can plug into this formula and get my x equals. Okay, so that's going to be my strategy. All right, so let's go ahead and find the theta. How do I find the theta? Well, I know it's a vertical tangent line. And what do I know about the derivative? Okay, remember, this is a regular derivative, like dy dx. I know you want to put dy d theta or dy dt, but this is just a derivative is equal to, what about a vertical tangent line? 1 over 0. Remember that? If it had been a horizontal tangent line, then I would have put 0 over 1. Okay, but this is a vertical tangent line, so I put 1 over 0. Well, remember, guys, what is equal to 0 here? D, my thing isn't working totally. dx dt, right? But this is d theta. So this up here is dy d theta, and this is dx d theta. And you can just memorize this. Anytime you want a vertical tangent line, what you really want is dx d theta is equal to 0. That's really what you want. And anytime you want a horizontal tangent line, you really could just start out with dy d theta is equal to 0. Okay, you can memorize it. I don't memorize it. I kind of do this every time. All right. All right. So what we want to do is set dx d theta equal to 0. Well, what is dx d theta? What is dx d theta? I don't have any x's here. Oh, wait. What's x equal to? Okay. So what I'm really doing is I'm saying d theta of x is equal to 0. But that's really d theta of r cosine theta is equal to 0, right? Okay, so what is d theta of r cosine theta? Well, what's r? It's given, right? So r is right here. We can plug in the r here. There's different ways to do it. We could take the product rule first, or we could plug in the r and then take the derivative. What would you rather do? It doesn't really matter. What do you want to do? Do you want to do product rule first, or you want to plug in the r and then take the derivative? You want to try plug in the r and then take the derivative? It doesn't really matter. Okay, I'm going to plug in the r. There's my r, cosine theta. I need to take the derivative of this. If I take the derivative of this, it's going to be a product rule. I don't know if I can avoid product rule. Let me see if I can avoid product rule by distributing. If I distribute, I'll get 2 cosine theta minus 2 sine theta cosine theta. No, I can't avoid product rule, but at least it won't be so bad. I'm going to take the derivative d theta of this. Okay, d theta of this whole thing. Are you guys with me so far? All right, what's the derivative of 2 cosine theta? Negative 2 sine theta. Okay, over here, this is going to be negative, so let me do positive negative here. Okay, I'm going to do product rule here. So I'm getting ready for my product rule. What I'm going to do is I'm going to make this negative stuck to this 2 sine theta. And these are my two products, two factors. All right, so it's going to be the derivative of the first, which is negative 2 cosine theta, times the second, plus the derivative of the second, which is negative cosine, negative sine theta times the first. Are you guys with me so far? Okay, so all I'm going to do is try to simplify this. So what I have is negative 2 sine theta minus 2 cosine squared theta. Negative is going to be a positive 2 sine squared theta is equal to 0. So what I want to do is solve for theta. That's my goal. Solve for theta. The problem here is I've got sines and cosines, and what I want to do is factor. What can I factor out? Let's see. Can I go ahead and factor out that 2? You guys okay with that? Let's go ahead and factor out a 2. I'll get negative 2 sine theta plus cosine squared theta minus sine squared theta equals 0. I didn't get your permission, but I'm going to factor out a negative 2, if that's okay. It doesn't really matter. I'm just trying to get a positive here. The thing is, what I'd like to do, okay, I'm just going to tell you this. It's because I'm a prophet that I know this, okay? So what I'd like to do is get all signs here. Because if I can get all signs here, I can factor this. So how do I change this to a sign? You guys good with that? If I change this to this, what will happen is, so let me carry this down, minus sine squared theta and sine theta. Okay, what will happen is this will add with this one. So what I get is sine theta plus 1 minus 2 sine squared theta is equal to 0. If I rearrange this, I can get negative 2 sine squared theta minus sine theta, plus sine theta, plus 1 is equal to 0. All I did was rearrange it. Okay, and if I change everything, then multiply everything by negative 1, I get 2 sine squared theta minus sine theta minus 1 is equal to 0. This is actually a good place to be. Does anybody see why this is a good place to be? You can actually factor this. You guys see it? It's almost the same as if I factored 2x squared minus x minus 1 is equal to 0. Just let my x equal sine theta, right? 2x squared minus x minus 1 equals 0. What would that factor be? Those factors be? Is that right, if I factored this? Right, so this is the same thing. It's just my x is actually sine theta. So this is going to be 2 sine theta plus 1 times sine theta minus 1 is equal to 0. And you can remultiply this, and you'll see that this will be, if you FOIL this, you will get this top, this top part up here. Okay, so what was my goal? Is to solve for theta. Okay, The goal is to solve for theta. So what I have is something times something equals 0. In algebra, that means one of these somethings is equal to 0. Either 2 sine theta plus 1 is equal to 0, or sine theta minus 1 is equal to 0. Okay? So this means sine theta is equal to negative 1/2 on this side, and this means sine theta is equal to 1. And what are all my thetas equal to? This is not it's not an arc sine theta, which means I'm not bounded by, I'm not bounded by, the rules for sine and tangent. I actually can make theta anything I want, and let's just stay between 0 and 2 pi since I'm in my cardioid. At what angle is my sine value negative 1/2? 7 pi over 6 and 11 pi over 6. Okay, what about this one? At what angle is my sine value 1 pi over 2? That's it, right? Okay, so I'm going to take all these angles. I'm going to plug into my cardioid here. Which one? Remember, I have 7 pi over 6. 11 pi over 6. What's the other one? Pi over 2. Which one's going to be 7 pi over 6? This one, right? Okay, which one's going to be 11 pi over 6? This one, right? Which one's going to be pi over 2? Yeah, this sharp term, but guys, since it's a sharp term, the derivative will be non-existent, right? So guys, you just ignore this. It gives you an extraneous value. On your test, you won't have an extraneous value, just FYI. Okay, so on your test, if you didn't graph it, you'd probably still be in okay shape. All right? Okay, right here, I've got my theta. If I have my theta, how do I find my r? Because in my x equation, I need r and theta. You plug in right here. You guys see that? Okay, so let me go back over here. Let me start all over. I'm going to say when theta is equal to 7 pi over 6, so let's say theta is equal to 7 pi over 6, my r is going to be equal to 2 minus 2 sine of 7 pi over 6, right? And so therefore, my r is going to be 2 minus 2 times, what's the sine? So let's think about this. What's the sine value of 7 pi over 6? Negative 1/2. So this is going to be equal to 3. Okay, so what I have here is r theta is equal to 3 comma 7 pi over 6. Okay, if r theta is 3 comma 7 pi over 6, what's x equal to? R cosine theta, right? Because I want to find what the x equals to right here. X is equal to 3 times the cosine of 7 pi over 6. And what is the cosine of 7 pi over 6? Is it negative root 3 over 2? So this answer is negative root 3 over 2 is equal to x. So right here, guys, my answer for this graph, for this line, vertical line, is x is equal to negative 3 root 3 over 2. And guys, just using symmetry, can you get what this one is over here? Just using symmetry. It should be 3 root 3 over 2, right? Just using symmetry. But we can check it also. So if we check it, what we're going to say is that theta is equal to 11 pi over 6. Okay, if theta is equal to 11 pi over 6, what's r equal to? You plug it into this formula, 2 minus 2 sine of 11 pi over 6. What's the sine value of 11 pi over 6? So 11 pi over 6 is here. What's your sine value? Negative 1/2. So what you get is negative 2 times negative 1/2, which is 3. So again, this r becomes 3, and your x is going to be r cosine theta, okay? But I know my r is 3 and my theta is 11 pi over 6, so this is 3 times the cosine of 11 pi over 6. And the cosine of 11 pi over 6 is root 3 over 3. So I do get what I thought I would get. Oh, wait, root 3 over 2, sorry. So I do get what I thought I would get, which is 3 root 3 over 2 is equal to x. Okay? How are you feeling about this problem? This is probably the hardest it gets, I feel like. Okay? But when your strategy always should be find your r, find your theta, first with your theta, you can get your R. Okay? If you can get that far, you got most of the test. Okay? All right, let's go ahead and pass up your warm-ups. And I'd like you to pull out your notes from last week. On Friday, we had some notes. The back side of your notes is what we're looking at today. Okay? Let's do it. We're looking at this problem here. It's on your notes, the back side of your notes from last week. Okay? And these are the notes for your homework for today. They give you an R. Okay? They tell you what theta is between. Theta is between 0 and pi. And they want you to draw this curve. You guys are pretty good at drawing curves. Can you do it? Let's do it. Okay? You want to sketch the curve. Oops, sorry, we're on letter A. We're going to sketch the curve. Okay? The way you draw a curve is you put theta on this side and R on this side. We know our R is equal to 2 plus sine 2 theta. Okay? We're going to put in some values for R. So let me put in the 45 degrees. So I'm going to put in 0. I'll put in pi over 4. I'll put in pi over 2. I'll put in 3 pi over 4 and pi. We only need to go from 0 to pi. So there's my picture right there. Okay. If I plug in 0, what do I get? 2. Right? If I plug in pi over 4, what do I get? Sine of pi over 2, which is 3. Right? If I plug in pi over 2, what do I get? 2 plus sine of pi, which is 2. If I plug in 3 pi over 4, what do I get? 2 plus sine of 3 pi over 2, which is, this is negative 1. That's going to be 1. And finally, if I plug in pi, what do I get? 2 plus sine of 2 pi, that's just 2 plus 0. Okay, let's plot it. Remember, you have to connect the dots in order, okay? So, when I face the 0 direction, I'm going to walk out 2 steps. When I face the 45-degree direction, I'm going to walk out 3 steps. So 1, 2, 3. When I face the pi over 2 direction, I'm going to walk out 2 steps. So face this direction up here, walk out 2 steps. 1, 2. Okay, let me go ahead and connect things before I forget. This one connects to this one. This one connects to this one. Okay, let's keep going. When I face the 3 pi over 4 direction, I walk out 1. And when I face the pi direction, I walk out 2. Okay? And this picture is pretty ugly. Okay? But it looks something like that. All right? And it really doesn't matter if you get it really detailed or not. Okay? When they ask you for the area, you're gonna, as long as you generally drew the picture right, you'll get the area right. Because let's think about this. On letter B, it says find the area bounded by this curve in the x-axis. So you guys are good. We're trying to find this area, right? It's the area of a polar curve. So guys, what's the formula for area of a polar curve? 1/2. Guys, don't forget the 1/2. So this is letter B. Area is 1/2. 1/2 what? The integral of r squared d theta. Guys, it's just a plug-in. Guys, you have no other formula for area except for this formula. So please, get this formula right. Okay, don't forget the 1/2. Don't forget to square the r. Where does the pi belong? Where do I put the pi? There is no pi. Okay, don't throw a pi in there either. Okay, so this is going to be 1/2 the integral of, what's my r? Yeah, they give it to me. So I just put it right in. What's my theta going to go? From what theta to what theta? 0 to pi. And it really can't get any easier than this. You're going to take this and you're going to put it into your calculator. Your calculator should never be in polar mode. Never, never, never. Okay? I guess you could do it if you wanted to plot it, but if you plot it, I would be like, change it back right away. Okay? Because other than that, it would never be in polar mode. And that's why I recommend that you guys don't, that you actually memorize how to do this, that you don't actually, that you actually know how to plot, that you don't actually need the calculator to plot. Okay. All right, so this problem, guys, I'm going to put it into my calculator, and that would be a math 9. Okay, your thetas are just going to be 0, or just going to be x's. You're going to trick your calculator. Your calculator doesn't know that these are x's, or these are thetas. Okay, I'm going to go from 0 to pi, and then I'm going to put in parentheses 2 plus sine 2 theta. Okay, again, make sure the whole thing is squared. So it's this whole 2 plus sine 2x quantity squared. Okay, and this will be with respect to x. Pray, hit enter, and I think I need to divide this thing by 2. I need to multiply by 1/2. So divide by 2, and I get 7.069. Can I get a second on that? Good. Okay, and that's how easy this problem is. You just enter it into a calculator. Make sure you enter it correctly, though. It's a little bit tricky. Let's look at letter C. Letter C is a little bit tougher. Letter C says find the angle that corresponds to the point on the curve with the x-coordinate, okay, with x-coordinate equal to -1. Okay, so what it's saying is, remember, this really is an xy plane. I know you guys think it's like a theta r and all that kind of stuff, but the theta r is embedded on top of this, okay? And what you want to know is here's your curve. Where does the curve hit x equals -1? Well, where is x equals -1? Right here, right? So they're just saying, what angle is this? This point right here, what's the angle? Okay? Well, it's the angle when x equals -1. Well, how is x equals -1? How does that look anything, like how do I correlate that with r and theta? How does x correlate with r and theta anyway? X equals r cosine theta. Guys, I'm just letting you know, if you forget anything on the test and you have an x or y, it's probably you forgot x equals r cosine theta. Okay? And all they want me to do is say x is equal to -1. I know that. They told me that. What's r equal to? 2 plus sine 2 theta. I know that. They gave me that. Okay? And I already have this cosine theta. So guys, I have an equation. The question is, what is theta? You guys see how easy this is? It's only easy if you know x equals r cosine theta. Okay, now right here, a lot of students, what they want to do is they want to change their calculator to polar mode. I'm just letting you know, if you change your calculator to polar mode, it won't do an intersect. Okay, so you're going to get stuck. This is just find what theta is, right? What if this theta had been x? Would you still find the same thing? What if this theta were a y? Would your calculator still do the same thing? Yes. So put this into your calculator, okay? Do y1, make your y1 equal to -1. Oops, which mine already is. So let me clear that so that, okay, we can start all over. Make your y1 equal to -1, okay? Make your y2 equal to this right side. So guys, remember, you can trick your calculator. Just make your thetas into x's. So this is going to be sine 2x. Get your parentheses right, though. There's 2 parentheses here. Times cosine theta. Okay? And then what we're going to do is we're going to graph this. And you're going to look for the intersection. Oh, my graph is going to be different because I zoomed it. Let me zoom out here, guys. Zoom. Oops, sorry. Zoom standard. Okay, so this is what your graph would look like on your calculator. Does it look something like this? Okay, and what am I trying to find? What am I trying to find? Where these things are equal, right? So the x value, and x is an angle is between 0 and pi. So this, I'm trying to find this x value right here, which is a theta value, okay? Because my x's here are thetas, all right? So let me zoom in on this point right here. You can do a zoom box, you can do a zoom in, whatever. I'm going to do a zoom box because I like the box. And let me just, oh. Okay. I'm going to pin my box, my left bottom. What am I doing? I'm going to pin my left bottom box over here. Get a rectangle here. So, not exactly what I wanted, but I think I got an intersection here. I'm going to box into this intersection and get the intersecting point right here. So that's going to be second, calc, intersect, go to the left of my point, enter, go to the right of my point, enter, press enter, and I'm getting 2.630. Are you guys getting the same? Okay, so there's my answer. And I know it's an x value, but remember I tricked my calculator, and the x's here really are thetas. All right, let's go to letter D. Letter D says, what is dr d theta if theta is equal to 5 pi over 7? And guys, you need to just use Leibniz notation to your advantage. All of the algebra works here, okay? If you don't know what to do, just start doing algebra, okay? Let's see, we want to find dr d theta. Okay, we want to find dr d theta. We know what theta is, okay? If I have r and I have theta, how do I get dr d theta? It's the derivative. It's the d theta of my r, right? It's the derivative of my r. But what is my r? It's the d theta of 2 plus sine 2 theta, right? What's the derivative with respect to theta of 2? 0. What's the derivative of sine 2 theta? 2 cosine 2 theta, d theta, which is just 1. And that's my answer. I know what theta is equal to. What's theta equal to? 5 pi over 7, right? So this is just 10 pi over 7, okay? This is your answer. I'm going to put it into the calculator because it asked me this question, and I'm going to show you why I want to put it into the calculator. Let's just get a number for this. So let me go to the home screen, and I'll have cosine of 10 pi divided by 7. Multiply that by 2. Can I get a check on this? I'm getting negative 0.445. Did you get that? Anybody get that? Okay, so this is equal to negative 0.445. And let's do units just for fun. It doesn't ask me for units. But this is R, and R is in meters. And this is theta, and theta is in radians. Okay, so what's happening here is I have dr d theta is equal to negative 0.445 meters per radians. And the question is, what does this tell you about R? Okay, and what it tells you about R is that, see if this makes sense. This is like in our old days, that R is changing, remember derivative, at a rate of negative 0.445 meters per radians. You guys remember that from our derivative days? To be able to say that? Okay. And then it says, what does it tell you about the curve? Okay, another thing is, if you wanted to, instead of changing, you could write decreasing, right? If you put decreasing here, make sure you change this to positive. Is everybody good with that? Because if it's decreasing, you already took the negative into account. So that's 0.445. It's safer just to say changing, okay? All right, but what does this tell you about the curve? What it tells you about the curve is this. If R is decreasing, then R is actually getting closer to the origin. Okay. Oh, let me make sure you understand this. Only at theta equals 5 pi over 7. Sorry, we need to add that in. It happens at theta equals 5 pi over 7. Okay. At other angles, it might be different. But when theta is equal to 5 pi over 7, R is decreasing at a rate of 0.445 meters per radian. And what that means is R is getting closer to the origin. Can you do that? That R is getting closer to the origin? That's what they're asking you for. I think this is a little bit vague here, but it was on the AP test. That's what they expected students to say. All right, let's look at letter E. Letter E is a little bit more challenging, but not something you can't do. Okay. And guys, when you're stuck with a problem that looks super like you don't know where to start, just write down your givens and start with the algebra. See if you can do the algebra. Okay, we're given our R. We're given d theta dt equals 3. We're given theta equals pi over 6. Those are all our givens. Okay? I'm trying to find out what dx dt is. What is dx dt? Okay, my problem is I'm looking at this and I'm like, what x? There is no x. Or is there? How does x correlate to r's and thetas? d dt of x, which is d dt of r cosine theta. Okay, if you're ever stuck on a polar problem, it's probably because you forgot x is equal to r cosine theta and y is equal to r sine theta. Okay. Does this help me? I need to take the ddt of r cosine theta. I need you guys to help me here. What would you do? Because there are several things you can do here, and I want to do what you would do. Okay, so on a test, what would you do? I'll plug in your r. So do you know what r is? It's right there. So what you know is this is d dt of 2 plus sine 2 theta times cosine theta. That's a good idea. Okay, that's a plus sign. All right. I'm still trying to find. I'm trying to find a number answer. Just letting you know, this should turn out to be a number. So I should be able to plug in everything here. What do I know about the derivative of this? Now, don't plug in. Remember, just like when we did related rates, never plug in your theta until you've taken the derivative. So make sure you take the derivative first. Otherwise, you're going to take the derivative of a number, and then, of course, your answer is always going to be 0, right? Okay, so always take the derivative first, then plug in your number. So do you want to take the derivative here? A question, do you want to simplify this before you take the derivative, or do you want to just take the derivative? Both are just as difficult, so it doesn't matter. Do you want to take the derivative, do product rule, or simplify and then do product, then do derivative? Simplify. Okay, let's simplify. If I simplify, what I'm going to do is take this cosine and distribute it. So what you'll get is d dt, okay, of what? Of 2 cosine theta plus sine 2 theta cosine theta. That's good so far. Okay, I'm taking the derivative of this whole thing with respect to what? T. And this has what in it? Theta. Whoa, that's going to be kind of funky. Okay, let's see how you do this. So what's the derivative of 2 cosine theta with respect to t? That's going to be negative 2 sine theta d theta dt, right? Okay, let's do the derivative of this. This is going to be product rule, right? So this is going to be, let's see, the derivative of the first, which is sine 2 theta, d theta dt, right? The derivative of the first times the second, which is cosine theta, plus the derivative of the second. So what's the derivative of cosine theta? Negative sine theta d theta dt. Derivative, wait, did I do this right? Derivative of the first times, okay, sorry. This should be 2, did I do this totally wrong? I'm going to start all over, sorry. Okay, derivative of the first, which is 2 cosine 2 theta, negative, right? Derivative of the first, oh, that's much better. You guys good with that? Derivative of the first times the second plus the derivative of the second. So the derivative of cosine theta is negative sine theta d theta dt times the first. Is that right? Is this positive right here? Oh, yeah, you're right. It is positive. You're right. Is this negative here? Yes. Okay. You guys are good so far? Thank you. All right. So I've done the ddt. But guys, remember, I know what d theta dt is. What is it? 3. So all these just get replaced by 3. Okay? I actually know, oh, this is a 3 too. I actually know what theta is. What's theta? Is it pi over 6? Okay, so this is pi over 6. This is pi over 6, so it's 2 times pi over 6. This is pi over 6. This is pi over 6. This is 2 times pi over 6. Okay, so let me simplify as much as I can here. 3 times negative 2 is going to be negative 6. Sine of pi over 6, so let's think about where pi over 6 is over here. Sine of pi over 6 is going to be 1/2, right? Okay, I've got the first term. All right, the next term. 2 times 3 is going to be 6. Okay, so that's 6. Cosine of pi over 3, because this is 2 pi over 6. So cosine of pi over 3, isn't that 1/2? And then times cosine of pi over 6, isn't that square root of 3 over 2? Okay, let's go to the third term. This is going to be negative 3 right here. So I'm going to carry the 3 over. 3 right here. Negative Sine pi over 6, so sine of pi over 6, is that 1/2? And then sine of pi over 3, because that's 2 times pi over 6, that's pi over 3. Sine of pi over 3 is square root of 3 over 2. Okay, so let me just simplify this. This is going to be negative 3. This is 6 and 2, so it's 1 and 3. Negative 3 plus 3 square root of 3 over 2 minus 3 square root of 3 over 4. You guys good with that? And this is, I'm just going to put this in the calculator because this is a calculator problem. And you could do some funky things with this, but let's just go ahead and figure out what this is in the calculator. 3 times the square root of 3, 3 times the square root of 3 divided by 2 equals. And then minus 3 times the square root of 3. Ooh, what is that? And then divide this by 4. And I'm going to subtract 3 from that. Okay, can someone give me a check on this? Negative 1.701. Okay, so this is negative 1.701. All right, can you do that by yourself? Okay, let's look at the question. The question is this. What is the meaning? At the instant theta is equal to pi over 6, what is the meaning of your answer? Okay, well, what did I find? I found dx dt. So this is dx dt is equal to negative 1.701 at theta equals pi over 6. Guys, what is dx dt? Think about what dx dt is. You know this from physics. What's dx dt? It's the rate, it's velocity, right? And so what this is it's x is changing at a rate of negative 1.701 at theta equals pi over 6. I can't get the units to this because I can't find a times unit on this problem anywhere. Do you have a times unit? I can't find it, so I just left it like this. Okay, but think about what this means. This means that x is going left, right? Do you remember this? When velocity is positive, you're traveling right? When velocity is negative, you're traveling left. So actually, if you look at the AP guidelines, scoring guidelines, they want to know that. I don't know why. Okay, the x is going left. Okay. All right. Any questions on this problem? This is it. This is all you need to know for this unit. Okay. What I want to do now is pull out number 9 and 10 on your homework for tonight, and start it with you guys so that it won't be too overwhelming. Okay. This homework looks long, but it's not. It's just that I spaced it out a lot so you guys would have room to work. Right. Let's look at 9 on your homework for tonight. This is worksheet 3. Okay. What they want you to find first is the area between r equals theta and r equals 2 theta, where theta is between 0 and 2 pi. I want you guys to think about this. We're going to graph this. What does r equal theta look like? Well, look, you put theta on this side and r on this side, right? But what is r equal to? Theta. So that means if you have 0 over here, what do you have over here? 0. What if I have pi over 4 over here? What am I going to have over here? Pi over 4. What if I have pi over 2 over here? What am I going to have over here? Pi over 2. What if I have, let's do quadrangles. What if I have pi over here? What am I going to have over here? Pi. Let's do 3 pi over 2. What will I have over here? 3 pi over 2. What if I do 2 pi? What will I have over here? 2 pi. Now the thing is, I need to change these to decimals because it's really hard for me to graph like how far pi over 4 goes out. So this is about 0.75. I'm just saying pi is 3. This is about 1.5, right? This is about 3. This is about 1.5 times 3. It's about 4.5. This is about 6. I'm just approximating here because I just want to graph, all right? Okay, so let's go over here and let's put in some tick marks. Okay, I'll put this online, but it's going to start at 0, 0. Then it's going to do this, 1.5. Then it's going to come around like this, and then it's going to come around like this. then it's going to come around like this, and then it's going to come around like this. Do you see what you get? That's going to be your first curve. Your second curve will be like this. You're going to find the area between these two spirals. So I'm just letting you know. You're going to punch out to the blue, subtract, punch out to the green. Does that make sense? Okay. So your answer is going to be, and I'll just give it to you guys here, 1/2 punch out to the blue minus punch out to the green from 0 to 2 pi. And I'll have this online for you guys. All right? Okay, good luck on your homework, guys. Number 10 is also a spiral. All right? And that'll help you guys to draw it.